Okay, so in the other videos, we looked at all of the pieces that go together to make a polynomial graph. And then in this one, we're going to put it all together. So let's say that we want to graph a polynomial. And this is actually going to be more of a sketch because we're not going to go into too much detail, but we're going to graph, let's do f of x equals 2, x minus 3 squared, x plus 1. Okay, so we're going to use what we know so far to graph this polynomial. So the first thing that we're going to do is we're going to find the zeros and their multiplicity. Oops. Okay, so remember the zeros come from each factor. The number out front isn't going to affect that because if we set each of these equal to 0, 2 equals 0 doesn't tell us anything. So a number out front doesn't affect anything, the x's do. So we've got x minus 3, that gives us a 0 at positive 3. We've got x plus 1, that gives us a 0 at negative 1. All right, and then the multiplicity goes with each of these. So each 0 has a multiplicity. This one has multiplicity 2. And at negative 1, we have multiplicity 1. Okay, so remember the zeros come from the factors, the multiplicity comes from the exponents. And then remember what the multiplicity tells us is what happens at that 0. So if it's even multiplicity, the graph is going to turn at that 0, and if it's odd, it's going to pass through at that 0. Okay, and then the other thing that we need to know about the graph is we need to know the end behavior. So that remember the end behavior comes from the degree. So the degree, we talked about this in the first video, is the highest exponent if this was all multiplied out. So we don't want to actually multiply these all the way out. We just want to figure out what the highest exponent would be. So you can either imagine what it would be if you multiplied it out. So I would have here, I would have x squared, and here I'd have x. So I'd have a total of 3 x's or x cubed. That would give me degree 3. The other way that you can do it is you can look at the multiplicity. If you add up the multiplicity, that's going to give you your degree as well. Okay, so that's two different ways that you can look at the degree. All right, now the degree is going to tell us what the ends do. So remember our power functions. If it's even, it looks like a parabola, and if it's odd, it looks like a cubic. So odd degree tells us that the ends look like a cubic, and we know that they're going to point in this direction because it's positive out front. If it was negative, then they would go in the other direction like this. Okay, so remember negative is a reflection down. So positive out front, like parabola up, parabola down, and odd degree tells us that we look on the ends like a cubic. All right, and then we should be able to put all this together to make a sketch. So let's put our zeros on. We've got a 0 at 3 and negative 1. And we know that our ends are going to be up on the right and down on the left. So we'll go ahead and draw those in, but we might have to move them just a smidge left or right to make the graph work, and that's okay, but at least that gives us a starting and ending point. And then we know what the multiplicity does. We turn and we go through, but we can't exactly tell where that is. We have to start from the arrows. So start from one arrow, go to the other. You're going to play connect the dots using your multiplicity. So coming up, our first, if we're coming from the left, our first 0 is at negative 1, and we're going to go through. So I'm going to go through that one. Okay, so we go through. And then I go to the next one at positive 3, I'm going to turn. So I come to the next one, and I turn, and I can kind of connect to that, or I can move it over a little bit. It's okay if you have to move it over a little bit as long as it's pointing in the right direction. Okay, and that's a sketch of our graph. Now for this class, we're not going to worry too much about, you could find this y-intercept easily, but we're not going to worry too much about the height of this bump. We're just going to draw it up and down. For those of you that are going into calculus, they've got a much better way to figure out where that bump is, much better than the way that we would do it. The other thing that you can notice about the graph is that the number of turns is equal to at most, the degree minus 1. So that should say maximum number of turns. Maximum number of turns is degree minus 1. So if I have degree 3, the most turns that I could have in the graph is 2. So see, I have one turn here, that's one bump, and then I have another one here, that's another bump. So the most that I could have in the graph is 2 turns. And you might not have 2 turns, but that's the most that you could have. So they might ask you that in the homework. We don't do too much with that one in this class. Again, that's more getting into calculus stuff. They've got better ways to deal with that. But they do ask you that in the homework, and it is good to notice you can't have more than that number of turns. Okay, you also need to make sure that your zeros match what you found from the function and what you found in the graph. You can't have extra zeros on the graph. So if you do something and let's say you like come through this one and come up again and you end up with another 0 here, you know that that's wrong because you don't have another 0 in your list. That can't be a 0 there. So then you come back and you realize, oh yeah, my multiplicity didn't match, or whatever. But your zeros have to match. You can't have extra zeros, and you have to have the ones that are here. Okay, let's try another one. All right, let's say we have f of x equals, let's do negative 2x, x plus 1, x minus 4 cubed. Okay, so we want the same 3 things as last time: zeros, multiplicity, and degree. Those are the 3 things that we need to know about the graph in order to draw it. So the first thing that you do is you look at the polynomial and you figure out the zeros. So remember, each x, each factor, is going to give you a 0. So the 2 out front doesn't matter, but this x does. So from the x by itself, we get 0. Here we get negative 1. And here we get positive 4. Okay, so I've got 3 different x terms. I get 3 different zeros. And then the multiplicity, remember, you get that from the exponent. So for the 0 at 0, we have exponent 1. At negative 1, we have exponent 1. And at positive 4, we have exponent 3. So all of these are odd, and that means that our graph is going to go through all of them. Oops, I think I left out a U. Through. Okay, so we're going to go through all of our zeros. And then the last thing to note is our degree. So you can either add up the multiplicity, or you can add up all the exponents on your x's. I've got 1 here, 3 here. That's a total of 5, or I can add up the multiplicity and get degree 5. Okay, so degree 5, that means that the ends, the degree is odd. The ends are going to look like a cubic. And this time we have a negative out front, so that's going to be a reflection. So our cubic is going to flip, and our ends are going to go this way. Okay, so this, what I'm looking at is this negative out front, and this is odd. So odd tells me that it looks like a cubic, and negative out front tells me that the arrows are going to flip. So we're going to go up on the left, down on the right. Okay, so those are the 3 pieces of information that you should be able to take out of this function. And then we should be able to draw it. So let's put our zeros on. So we've got 4, negative 1, and 0. We know that our arrows are going to go up on the left and down on the right. And now we play connect the dots. We're going to go through all of them, so that makes it easy. We don't have to keep track of which one's which. So we're going to go through, and then we're going to go through, and then we're going to go through. Okay, and again, yours might look a little bit different from mine, or it might look a little different from the calculator, depending on, we don't really know how far this bump here is going, so it might go a little bit farther. We're just trying to get a sketch of it. And we can get a pretty good sketch for just a little bit of information. We have an idea of what this polynomial looks like. Okay, and then we can notice again that the maximum number of turns is equal to the degree minus 1, which is 4. And we don't have 4 turns. We actually just have 2. So it can be less than that number. Okay, we just have 2 turns to this one, So it can be less than that number, that's just the maximum. Okay, and that's the basic idea for graphing these. Now, if you want to work in reverse, it kind of goes the same way. So on some of them, they give you a graph and they want you to find the function. So let's just do one of these real quick. Okay, let's say that we've got a graph that looks like this. All right. All right, and let's say that we're given some functions to match it to. So I don't have a whole bunch of functions listed out, but let's see what we can make of this. So I have zeros at -3, 0, and +3. That means that I know that I have factors at x plus 3, x by itself, and x minus 3. Let's put that in a better order. Okay, there might be a number out front, but we can't really tell that just by looking at the graph. The other thing that we can figure out is we can figure out the degree and the multiplicity. So I see that I have two arrows going in the same direction. That means that my degree's got to be even. And looking at my function here, my degree is not even. I have 1, 1, 1. That's 3. That's an odd degree. So I've got to figure out the exponents here. So this one passes through. That would have to be an odd exponent. So it could be 1, 3, 5, any of those. For simplicity, let's just say that it's a 1. So that is this one right here, the middle one. So let's just leave that as a 1. And again, this would be a matching scenario, so you would just look for the odd multiplicity. At 0, we've got a turn, which means that our multiplicity has to be even. So at 0, maybe that's a 2. It's got to be something even. And then at +3, that passes through, so that's got to be something odd. So we can leave that as a 1. So now check. Our degree is now 4, because I changed the exponents. The degree is now 4, and that agrees with my arrows going in the same direction. Even degree is like an even power function, which is like a parabola. And I'm going to have a positive number out front because they're pointing up. Okay, so my best guess at this function is this right here. Okay, and again, it would be a matching scenario. So you would just figure out which one has even multiplicity, odd multiplicity, and make sure that everything matches. Okay, so we know how to take the function and graph it, and we know how to take a graph and match it to a function.